Hello everyone, in this video we're going to go over the 2025 AP Calculus AP free response questions. Free response question 1. An invasive species of plants appears in a fruit grove at time t equals 0 begin to spread, right? And the function c of t is given by this guy. And c prime of t is given by this one, where t is measured in weeks, right? Now, question A, find the average number from time t equals 0 to time equals 4, right? So you're going to use the average value formula, right? So you just substitute values 1 over 4 minus 0 in the row form 0 to 4. The function c of t is given by this one right here. So you have 7.6. Alright, so you bring up the calculator, hit calculate, and then you're going to hit menu, calculus, numerical intro right here. Right here you hit 0, this one should be 4. Alright, and you hit enter. The answer is 11.1129. Now you need to divide by 4, right? Hit enter. It's going to be 2.778. Now question B. Find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval 0 to 4. Alright, so you have average rate of change is going to be c of 4 subtract c of 0 over 4 minus 0, right? So it's going to be multiply by 4 subtract 7.6 tangent of 0.2 multiply by 0 divide by 4, right? So you bring up the calculator and then you're going to hit enter. The answer is 1.28201, right? 38 over 25 plus t squared equals 1.28201, right? Now you're going to bring up the calculator, you're going to grab this one, and you're going to find the intersection, right? 38 over 25 plus s squared. And then you close parentheses, right? Now you hit tab for the second equation. 1.28201. And you hit enter. It's going to be right here. Now remember that the interval from 0 to 4, right? So you need to find the intersection. It should be right here, right? So you need to hit menu, number 6, analyze graph right here, and intersection right here. Move to the left of intersection, hit enter, move to the right, hit enter. So the answer should be 2.154 right here, right? So t equals 2.154 weeks. Alright, let's move on to question C. Assume that the invasive species continues to spread according to the given model for the time t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Alright, so question C very simple. It's going to be limit of c prime t when t approaches infinity. It's going to be limit of the function 38 over 25 plus t squared when t approaches infinity. Now, this is a rational function when the degree on the numerator is less than the degree on the denominator. So, this guy has the horizontal asymptote y equals 0, right? So when t approaches infinity, this guy approaches the horizontal asymptote, which means 0, right? Now question D. At time t equals 4 weeks, after invasive species appears in the fruit growth, measures are taken to counter the spread of the species. The function a divided by a of t equals c of t minus this guy. Models the number of acres affected by the species over the time interval t greater than or equal to 4, less than or equal to 36. At what time t, for t from 4 to 36, does A attain its maximum values? Justify your answer. So even though you're allowed to use calculator, you need to justify this one, right? So when it comes to maximum, minimum, increasing, decreasing, think about the first derivative, right? So I have AT equals CT right here. I need to take the derivative first, right? So I have a prime of t equals c prime of t minus. Now when you take the derivative of this one, it's going to be 0.1 times natural log of t, right? So alright, now you're going to let a prime of t equals 0 is the same thing as c prime of t minus 0.1 natural log of t equals 0, right? Now c prime of t is going to be given right here, 38 over 25 plus t squared minus 0.1 natural log of t equals 0, right? Now I'm going to add 0.1 times natural log of t both sides, right? So this guy turns out to be... Alright, now I'm going to put this one on the calculator. Alright, the first graph is the blue one, right? The second graph should be 0.1 natural log of t, right? So I need to hit tab. I put 0.1 natural log of s. And I hit enter. So you will see it. The intersection should be right here, right? So I need to hit menu, analyze graph, intersection. Now I move my cursor to the left of intersection, move my cursor to the right of intersection. The answer is 11.44, right? Now I need to calculate A of 11.44, A of 4, and A of 36, right? And I'm going to pick the maximum values, right? So the function A is given by this one right here. So I just rewrite this one over here. Now I need to calculate A of 11.44. So I'm going to bring up the calculator. I hit 7.6 attention of 0.2 times t, but t equal 11.44, right? And then I need to subtract the interval from 4 to t. So I hit menu, calculus, numerical interval. Now I'm going to hit 4 to 11.44. The interval of 0.1. Natural log of s ds. Alright, so I just hit enter. The answer is 7.316, right? 7.316. Now you're going to do exactly the same thing for A of 4 and A of 36. So A of 4 you will get 5.128. And A of 36 you will get 1.743. The final answer must be this guy right here, right? So you need to conclude that at time t equals 11.44 weeks, A obtain the maximum values 7.316 acres. Free response question number 2. The shaded regions R is bounded by the graphs of the functions f and g square f of s equal s squared minus 2s and g of s equal s plus psi pi s as shown in the figure right here. Now keep in mind the function g of s is above the function f of s. Alright. Question A. Find the error of the region R. Show the step for your calculation. Alright, so basically you have the error of the regions equals the interval from 0 to 3, right? Now, since the g of s above f of s, so it's going to be g of s subtract f of s, right? And don't forget to put ds. So it turns out to be interval from 0 to 3. Now, g of s is going to be this one right here, s plus psi pi s. And subtract f of s is going to be s squared minus 2s ds, right? Alright, since this one is calculator active, so we're going to bring up the calculator. Alright, now you're going to hit menu, calculus, number 2. The interval from 0 to 3. And you hit enter. The answer is 5.136, right? Now question B. The region R is the base of a solid. For this solid, H is S. The cross-section perpendicular to the x-axis is a rectangle with height S and base in region R. Find the volume of the solid. Technically, volume equals the interval from 0 to 3. Alright, length times width, right? Now, the length, which means the height of the rectangle, is going to be s right here, right? So I'm going to put s outside, right? Now, the width is going to be the function g of s subtract f of s, right? So I have g of s right here, subtract f of s times s ds, right? Alright, so it turns out to be the interval from 0 to 3 of s plus psi pi s minus s squared minus 2s times s ds, right? Now you're going to bring up the calculator. So I'm going to copy this one down. Alright, I just put S right here. Hit enter. The answer is 7.704, right? Now question C. Write but do not evaluate an integral expression for the volume of the solid generated when the regions R is rotated about the horizontal line y equals -2. Alright, so here's the y equals -2, so you have the horizontal line is going to be like this. Alright, so if you rotate this one about this line, it's going to be something like this. You need to find inner radius and outer radius. Alright, so the outer radius, which means g of s subtract -2, right? And inner radius should be f of s subtract -2, right? So you have the formula, the volume equals pi, the interval from 0 to 3, outer radius, which means g of s subtract -2 altogether square minus f of s subtract -2 altogether square ds, right? Now it turns out to be pi interval from 0 to 3 g of s, which means s plus sine pi s subtract -2, which means you're gonna add 2, right? Square minus s square minus 2s plus 2 altogether square ds, right? Then this is the final answer. You don't need to evaluate it, right? Because it says do not evaluate. Now question D. It can be shown that g prime of s equals 1 plus pi cosine pi s. Find the values of s for s from 0 to 1, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Alright, so if two lines are parallel, they have the same slope, right? So the slope of the function g is given by this one right here, right? So you have question D. So you have g prime of s equals f prime of s, right? Now g prime of s is going to be 1 plus pi cosine pi s. Now f prime of s, f of s equals this one right here. You take the derivative of this one. It's going to be 2s minus 2, right? So this guy 2s minus 2, right? Now you're going to put this guy on the calculator. It's going to be 1 plus pi cosine pi s. And hit enter. It's going to be this. Now I'm going to hit tab to put the second one, not 2. And then I'm going to hit enter. It's going to be right here. Now I need to find the intersection between these two guys where s from 0 to 1. So keep that in mind. So you need to limit the domain. It's going to be from 0 to 1. So now I need to hit menu, window. I hit window setting right here. As min I put 0. As mask right here I just put 1. Alright, I hit enter. Alright, so the intersection should be right here. Right? This guy right here. Now I need to hit menu, analyze graph, number 4. Go to the left of intersection, hit enter. Go to the right, hit enter. The answer is right here. 0.6758. And then you're going to round this one up. It's going to be 0.676, right? Free response question 3. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. Selected values of r of t are given in the table below. Question A. Approximate r prime of 1 using the average rate of change of r over the interval 0 to 2. Alright, now you have question A using average rate of change, right? So r prime of 1 equals r 1 right here between 0 and 2. So you have r2 minus r0 over 2 minus 0, right? R2 is going to be 100, R0 is going to be 90, right? So you have 100 subtract 90 divided by 2. So it could be 5 words per minute, right? The units right here, words per minute. Now, question B. Must there be a value of C for C between 0 and 10 such that R of C equals 155? Justify your answer. Alright, so this is actually we're going to use intermediate value theorem, which is IVT, right? Now, in order to use IVT, you need to make sure the function is continuous we look at this one, we see that the function r is differentiable. And then you know that if the function is differentiable, it's going to be continuous. Alright, if the function is continuous, it's not necessarily differentiable. So be careful. So you need to say, since the function r is differentiable, then it is continuous. Now we're going to check r0, r10. r0 equals 90, right? r10 equals 162, right? This guy less than 155 and 155 less than this one, right? But 155 is r of c, right? So you have r of 0 less than r of c less than r of 10, right? So you need to say by the intermediate value theorem, there must be a number c where c from 0 to 10 such that r of c equals 155. Alright, let's move on to question C. Use the trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of this guy. Show the work that leads to your answer. Alright, so 3 subinterval is going to be right here. From here to here, delta S equals 2. From here to here, delta S equals 6. From here to here, delta S equals 2, right? Remember that the trapezoid error formula is given by base 1 plus base 2 times the height divided by 2. Now, from 0 to 2, base 1 is 90, base 2 is 100. The height is 2 right here, right? So you have question C. The error is given by the interval from 0 to 10 r of t dt. It's going to be base 1 equal 90 plus base 2 is going to be 100 times the height, which means delta S equal 2 divided by 2 plus the second one right here. Base 1 is 100, base 2 is 150, the height should be 6, right? So it could be 100 plus 150 times 6 divided by 2. Now plus the third one, 150 plus 162 times 2 divided by 2, right? 150 plus 162 times 2 divided by 2, right? 190 plus 750 plus 312. Then the final answer must be 1252 volts. Now let's move on to question D. A teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function W divided by this guy, where Wt is measured in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? Because this is the function of the rate of change, right? So technically, you just integrate this one. D is going to be integral from 0 to 10 of negative 3 over 10 t squared plus a t plus 100 dt, right? So it's going to be negative 3 over 10 times t power of 3 over 3 plus 8 t squared over 2 plus 100 t. Evaluated this one from 0 to 10, right? Now you need to simplify this one. 3 and 3 cancel out, right? This is a divided by 2, it's going to be 4 right here, right? So I substitute 10 over here, it's going to be 1000 divided by 10, it's going to be negative 100, right? 10 substitute over here, it's going to be 100 100 times 4 is going to be plus 400, right? And this guy is going to be plus 1000, right? 0 substitute over here is going to be 0. So the answer should be 1300 words. Free response question number 4. Alright, the continuous function f is defined on the closed interval -6 to 12. The graph of the function f consisting of 2 semicircles and 1 line segment as shown below. Now, let the function g be the function defined by g of s equals interval from 6 to s f of t dt. Find g prime of a. Give a reason for your answer. Alright, question A, very straightforward, right? You need to calculate g prime of s first, right? G prime of s, so you need to take the derivative of this guy right here, right? It turns out to be f of s, right? Now, g prime of 8 is going to be f of 8, right? Now, f of 8 is going to be right here. So the answer is 1. Now, let's move on to question B. Find all values of s in the open interval -6 to 12, at which the graph of g has a point of inflection. Alright, so when it's come to point of inflection, you need to calculate the second derivative, right? So we have g double prime of s is going to be f prime of s, right? You just take the derivative of this guy right here. Alright, now f prime of s, which means the rate of change of the function f, or the slope of the function f, right? Now, in order for the function g have a point of inflection, g double prime of s must change sign from positive to negative, or negative to positive, right? Now, you look at the graph f prime of s, which means the slope of the function f of s right here. So you need to draw the tangent line, right? So the tangent line is going to be right here and right here, right here and right here, right? And you use the Christmas tree trick. If the lines go in this way, slope is positive. Lines go in this way, slope is negative, right? So this one slope is negative, this one slope is positive, right? So it changes sign at s equal -3 right here, right? And the second one is going to be 3 right here, right? Because this is positive and this is negative, right? And the last one is going to be 6 right here, because this one is negative and the slope of this line right here is going to be positive, right? So you have 3 values, -3, 3, and 6, right? So you have s equals -3, 3, and 6. Now let's move on to question C. Find g of 12 and g of 0. Alright, so we have g of s equal this guy right here. So you have g of 12 is going to be interval from 6 to 12 f of t dt, right? Now, since this guy and this guy the same, right? So you just change this one to s, right? So interval from 6 to 12 f of s ds, so that you can use the graph right here, right? Now, 6 to 12, which means this region right here. Alright, so this is the right triangle. The area of the right triangle is base times height divided by 2. The base is 6 units. The height is 3, right? So you have 1/2 3 times 6, right? So it could be 9 units, right? Square. Now, g of 0 is going to be interval from 6 to 0 f of t dt. So it's going to be negative interval from 0 to 6. You just swap the bound right here and you change the sign, right? So it could be f of s ds, right? So it could be negative. Now from 0 to 6, it could be the semicircle right here. Alright, so the area of the semicircle is going to be 1/2 pi r square, right? The radius is 3, right? Because this one is the center. So you have 1/2 times pi times 9, right? So I put it over here. It's going to be negative 1/2 times pi times 3 square. So it could be negative 9 pi over 2 square units, right? Now let's move on to question D. Find the value of s at which g attains an absolute minimum on the closed interval -6 to 12. Alright, so when it comes to absolute minimum, maximum, increasing, decreasing, you need to use the first derivative, right? So we have g prime of s equals f of s, right? From the question A. Now, you need to find the critical point, right? In order to find the critical values, this guy right here must be equal 0 or undefined, right? Now, we look at the graph right here, f of s equals 0, it's going to be right here, the first 0 right here, -6. The second 0 right here is going to be 6. And the last 0 right here is going to be 6, right? So you have s equals -6, 6, and 0. Now you need to find the values of g of -6, g of 6, g of 0. And don't forget the interval right here. -6 to 12, right? So you need to check the endpoints. -6, we already have it right here. And the last one we have g of 12, right? Now g of -6 equals this guy right here. Interval from 6 to -6, f of t dt, right? So it's gonna be interval from -6 to 6, and we need to change the sign right here, f of s ds, right? Again, this guy the same. We can replace t with s, right? Now interval from -6 to 6 is gonna be this guy right here. Now the net error should be 0, right? Because this one is positive, this one is negative, and they're both the same, right? So when you add them up, it's gonna be 0, right? Now g of 6 is gonna be the interval from 6 to 6, f of t dt. So it could be interval from 6 to 6, f of s ds, right? Now this guy have the same bounds. So the answer must be 0. Remember, you have the formula, the interval from a to a, f of s ds always equals 0. So keep that in mind. Now g of 0, we got it from question C right here. The answer is -9 pi over 2, right? And g of 12, we got it right here, 9, right? Now we need the absolute value minimum, right? So the answer must be this guy right here, right? So find the value of s. So s must be s equals 0. This is the final answer. Free response question number 5. All right, two particles h and j are moving along the x-axis for t from 0 to 5. The position of particle h at time t is given by as h of t equals e to the t squared minus 4t, and the velocity of particle j at time t is given by vj of t equals 2t times t squared minus 1 cubed. Find the velocity of the particle h at time t equals 1. Alright, so particle h is right here. This one is the position function, right? So in order to find the velocity, you need to take derivative, right? So question A, v h equals s h derivative, right? So it's going to be e to the t squared minus 4t, take derivative of this one, right? So you need to use the formula e to the u derivative. It's going to be e to the u times u prime. So it's going to be e to the t squared minus 4t times t squared minus 4t derivative, right? And then it's going to be 2t minus 4 times e to the t squared minus 4t, right? Now you need to substitute t equal 1 into this expression. So you have v h of 1 equals 2 times 1 is going to be 2 minus 4 is going to be negative 2 times e to the 1 square minus 4 times 1. So it's going to be negative 2 e to the negative 3. This is the final answer. Now let's move on to question B. During what open intervals of time t for t from 0 to 5 are particles h and j moving in opposite direction? Give a reason for your answer. Alright, so in order to do this question, we look at the function vh of t and vj of t. We need to find the zero of these two functions, right? So question B right here. Now I need to find the zero for the first function vh of t equals 0. So it's going to be this guy right here equals 0, right? 2t minus 4 times e to the t squared minus 4t equals 0. Now this one is the zero product, right? So each of this one must be equal 0, right? But this one right here always positive, right? So we only need 2t minus 4 equals 0, and then we solve it. So t equals 2, right? Now the second one, vj of t equals 0, which means this one equals 0, right? So it's going to be 2t times t squared minus 1 q equals 0. So this one is the zero product. So each of this one should be equal 0, right? So you have 2t equals 0 and t squared minus 1 q equals 0, right? So it turns out to be t equals 0, right? And this one right here, you have t equals plus and minus 1, right? Now you put this one on the number line and you check the sign, right? Remember that the interval from 0 to 5 is 0. This one is 5. Now this is vh of t. The second one is going to be 0, 5. And this is vj of t, right? For the first one, t equals 2 right here, right? So t equals 2. Now I need to pick a number within this interval right here. So I pick number 1, right? I substitute back to the function vh of t, which means this one right here. Now I need to check to see if this one is positive or negative, right? So 2 times 1 minus 4 is going to be negative 2. This one positive, so this one must be negative, right? This one should be positive, right? Now the second one right here, I have 3 critical values right here, right? But negative 1 is outside of this domain, right? So I don't need negative 1. 0 is not going to be in the domain, right? Because it's going to be greater than 0, right? So final values right here should be t equals 1 only, right? So I put 1 right here. It should be on the left right here because this is 1 is 2, right? Now I need to check the sign of this guy, right? I'm going to pick the number 2 within the interval 1 to 5. I substitute into the function vj of t is going to be right here, right? So 2 substitute over here is going to be 4 times 4 minus 1 q is going to be positive, right? So this interval is positive, and then this one must be negative, right? Now I'm going to go back to question B. It says H and J are moving in opposite direction, right? Which means they have opposite sign, right? Now look at the first function right here. From 0 to 2, it's going to be negative, right? I'm going to put 1 right here to see what happens, right? From 0 to 1, this is negative. From 1 to 2, it's going to be negative, right? Now I'm going to put 2 right here, right? Now from 2 to 5, this is positive already, good, right? Now this one from 0 to 1, it's going to be negative right here. From 1 to 2, it's positive, right? Because the interval 1 to 2 is inside the interval 1 to 5, right? 1 to 5 is positive and 1 to 2 must be positive, right? We're going to look at the sign. Interval from 2 to 5, they both positive, right? Interval from 0 to 1, they both negative, right? So they're going to be the same direction, right? But interval from 1 to 2, they're going to be in opposite direction because the sign opposite, right? So the answer must be 1 less than t less than 2. Now let's move on to question C. It can be shown that v prime j of 2 greater than 0 is the speed of the particle j increasing, decreasing, or neither at time t equals 2. Alright, so now in order to know if the speed of the particles is increasing or decreasing, we need to check the sign of the velocity and acceleration, right? Now v prime j of 2 greater than 0 is the same thing as a j of 2 greater than 0, right? Now we have v j of 2 is the function vj is given right here. Now we substitute 2 into this expression right here. So we have 2 times 2 times 2 square minus 1 cube, right? So it's going to be 4 times 3 cube, right? So it's going to be 108, which is positive, right? Now since acceleration and velocity have the same sign, they're both positive, right? The speed of the particle is increasing. Now side note, if V positive, A positive, or V negative, A is negative, both of this one make the speed of the particles increasing. If V positive, A is negative, V negative, A positive, the speed of the particle is decreasing. So keep that in mind. Now let's move on to question D. The particle J is at position s equals 7 at time t equals 0. Find the position of the particle J at time t equals 2. Alright, so we need to use the fundamental theorem of calculus. We have the integral from a to b of f of s ds is going to be f of b minus f of a, right? Now in this situation, we have the integral from 0 to 2 v j of t dt equals s j of 2 minus s j of 0, right? Now vj is going to be right here, right? So we have the integral from 0 to 2 2t times t squared minus 1 q dt equals hj of 2 minus hj of 0 is going to be right here 7, right? Because t equals 0. So you need to minus 7. Now you're going to calculate this one by doing the u substitution, right? So let u be t squared minus 1. So you're going to take derivative both sides. So it could be du equals to t dt, right? Now you need to change the lower limit and upper limit. The lower limit t equals 0, upper limit t equals 2, right? So this guy turns out to be u equals 0 substitute over here is going to be negative 1. 2 substitute over here is going to be 3, right? Now so you have as j of 2 equals this one right here turns out to be integral from negative 1 to 3. Alright, 2t dt can be written as du, right? T squared minus 1 can be written as u, and then you have q right here, so you put q, right? You need to add 7, right? Add 7 both sides. So this guy turns out to be u power 4 over 4, evaluated from negative 1 to 3 plus 7, right? So it could be 81 over 4 minus 1 over 4 plus 7, right? 81 minus 1 is going to be 80 divided by 4 is going to be 20 plus 7. So the answer is 27. Free response question number 6. Alright, consider the curve G divided by the equation y cubed minus y squared minus y plus 1 over 4 s squared equals 0. Show that dy over ds equals this guy. Alright, so basically we just take derivative both sides, right? So we have question A. dy over ds of y cubed minus y squared minus y plus 1 over 4 s squared equals dy over ds of 0, right? Now this guy turns out to be 3y squared dy over ds minus 2y dy over ds minus dy over ds, right? Plus 1 over 4 times 2s equals 0, right? Now we're gonna factor dy over ds out, right? So it turns out to be 3y squared minus 2y minus 1. Now we're gonna simplify this one. It's gonna be 1/2 s, right? So we subtract 1/2 s both sides, so it could be 1/2 s, right? Then we divide both sides by this guy. So dy over ds equals negative s over 2 times 3y squared minus 2y minus 1. Alright, and this one is the answer. Now let's move on to question B. There is a point P on the curve G near this one, with x coordinates equal 1.6. Use the line tangent to the curve at this point to approximate the y coordinate of point P. Alright, so we're going to use the point slope form formula to do this question, right? So we have y minus y1 equals m times s minus s1. Now note that s1, y1 is going to be this point right here, 2, negative 1, right? And then m, which means this one right here. This one equal m, the slope right here. Now we need to evaluate this one when s equal 2, y equals negative 1, right? So I have m equals dy over ds. So it's going to be negative s squared 2, so it could be 2 right here, over 2 times 3 times negative 1 square minus 2 times negative 1 minus 1, right? Now we're going to simplify this one. It turns out to be negative 1 over 4, right? Now we have the equation y equals m, which means negative 1 over 4 times s minus s1, which means 2, right? Now you look at this one, y subtract y1 equals negative 1, so you subtract negative 1 should be plus 1, right? Now you need to subtract 1 both sides, so I have negative 1 right here, right? So then I have y equals negative 1 4 times 1.6 minus 2 minus 1, right? So it turns out to be y equals negative 1 4 times negative 0.4 minus 1, right? So it's going to be y equals 0.1 minus 1. It's going to be negative 0.9, right? Question C. For x greater than 0, y greater than 0, there is a point S on the curve G at which the line tangent to the curve at that point is vertical. Find the y coordinate of the point S. Alright, in order to do this one, we're going to use the Christmas tree trick. If the tangent line is going this way, the slope is positive. If the tangent line is going down this way, the slope is negative. If the tangent line is horizontal, the slope is 0. If the tangent line is vertical, the slope is undefined, right? So, in this situation, the slope should be undefined, where the tangent line is vertical, right? Now, you see that the slope is going to be right here, right? In order for this one to be undefined, the bottom right here must be equals 0, right? 2 times 3y squared minus 2y minus 1 equals 0. Divide both sides by 2, so you have 3y squared minus 2y minus 1 equals 0. Now we need to factor this one. So you need to find two integers multiply equals 3 times negative 1, which means negative 3. Add up to negative 2 right here. So two integers are negative 3 and 1, right? So you have y minus 3 times y plus 1 equals 0, right? Now keep in mind, this is not the final factor form because a equals 3, right? So you need to divide the constant right here by a, which means 3. This guy divided by 3, and you solve for y, right? So y equals 3 and 3 right here, cancel out. It's going to be 1, right? Now you have the 0 product, so y minus 1 equals 0 and y plus 1/3 equals 0. And then you solve for y. So y equals 1. Y equals negative 1/3, right? Now we look at the restricted domain right here. Y greater than 0, right? So you need to eliminate this one right here, right? So final solution should be y equals 1. Now let's move on to the question D. A particle moves along the curve H defined by the equation 2sy plus net log of y equals 8. At the instant when the particle is at a point 4, 1, ds over dt equals 3. Find dy over dt at the instant. Alright, so we just take the derivative of this one with respect to t, right? So we have 2s dy over dt plus 2y ds over dt, right? Plus derivative of natural log of y equals 1 over y, right? So it can be 1 over y dy over dt, right? Equals derivative of a equals 0, right? Now we substitute values. S equals 4, y equals 1, ds over dt equals 3, right? So we have 2 times 4 times dy over dt plus 2 times 1 times 3, right? Plus 1 over 1 dy over dt. Now we're going to simplify this one. So 2 times 4 equals 8, right? And then you need to combine this one right here, 1 right here. So it could be 9 dy over dt. This one equals 0, right? 2 times 1 times 3 is going to be 6, right? Subtract 6 both sides, so it could be negative 6, right? So dy over dt equals negative 6 divided by 9. Now we're going to simplify this one. It's going to be negative 2/3, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand